Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. It's from the sample of problems published by Society of Actuaries, exam P on probability. Two independent estimates are to be made on a building damaged by fire. Each estimate is normally distributed with mean 10b and variance b squared. Calculate the probability that the first estimate is at least 20% higher than the second. So let's write x1 for the first estimate and x2 for the second estimate. Let's write phi for the cumulative distribution function of a standard normal distribution and z, that would be a standard normal random variable. Then we're looking for a probability that x1 is greater than 1.2 x2. Well, it's the same as probability that x1 minus 1.2 x2 is positive, which is the same as the probability that x1 minus 1.2 x2 minus the mean of that random variable, x1 minus 1.2 x2, divided by the standard deviation of that random variable, x1 minus 1.2 x2, is greater than, and we subtract the same expected value from 0 and divide by the same standard deviation on the right-hand side. Of course, 0 doesn't need to be there anymore, so we just left with minus the expected value over the standard deviation. And x1 minus 1.2 x2 is normal because it's a linear combination of two independent normal random variables. Therefore, once it's standardized by subtracting the mean and dividing by the standard deviation, it becomes standard normal. So the left-hand side of that inequality is a standard normal random variable. And the right-hand side, well, is the mean, which is 10b minus 1.2 times 10b, because the mean of x1 and x2 is 10b, divided by the square root of the variance of x1 minus 1.2 x2, which is the variance of x1 plus 1.2 squared times the variance of x2, and both of these are b squared because the standard deviation of x1 and x2 is b. And then we can just cancel b from the top and the bottom of this fraction because the square root of b squared is b. And we factor out b squared from both expressions under the square root, and then we take the square root of b squared becomes b, and it cancels with the b, which is in the numerator. And then in the numerator we're left with 10 minus 12, which is negative 2, and the denominator we have the square root of 1 plus 1.2 squared. But it's really probability that z is greater than minus negative 2 over square root of 1 plus 1.2 squared. That's the same as probability that z, standard normal random variable, is greater than 2 over square root of 2.44. It's approximately the probability that z is more than 1.28036880, and that's 1 minus the cumulative distribution function at the same, evaluated at the same number, of course CDF of a standard normal random variable. Of course, this 1.28 and so on, that's almost exactly the 90th percentile of the standard normal distribution, so phi of it is 0.9, so 1 minus 0.9 is 0.10, and that's answer B. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.